Hello, dear friends, students, and learners. It's Dr. Bhatt here. Today, again, the topic is aldol condensation. If we recall, we had already an idea about what is aldol condensation, what are the conditions of aldol condensation to occur, and what are the different types of aldol condensation. We have learnt about simple aldol condensation, which may be between the two aldehydes, or an aldehyde or a ketone, or maybe between the ketones itself. And then the basic condition was that the one of the aldehyde must contain an alpha hydrogen atom. And this way we have learned sufficient details about simple aldol condensation, mixed or cross aldol condensation, and also the intramolecular aldol condensation. It's all right, okay, but then our studies are never complete unless and until we go through the mechanism of aldol condensation, how it occurs, what are the role of electrons to bring about this aldol condensation, and the resonating structure of carbonyl group. Now, before we get into certain details about the mechanism of aldol condensation, it would be worthwhile to review the resonating structure of carbonyl group. As we find that the carbon atom is bonded to the oxygen atom in a carbonyl group through a sigma and a pi bond. Still, the oxygen atom contains two lone pair of electrons. Of course, the carbon can be attached to the two alkyl groups, or it may be attached to two hydrogen atom, or might be to one hydrogen and one alkyl group. So that way aldehydes and ketones are created, molecules are formed. Now what happens here, as you find that there is a sigma bond, there is a pi bond, which are in between the carbon and oxygen atom, and oxygen atom is still having two lone pair of electron. We know that oxygen is more electronegative than carbon. So this, you can say that oxygen still has got a tendency to take up electrons, and pi, under this situation, the pi bond being weaker as compared to the sigma bond, it breaks and electron is transferred from pi, electron is transferred to the oxygen atom. That way a new canonical form of carbonyl group is created. That is, these are the two resonating structure. But during this process, what has happened? The oxygen has become negatively charged and carbon is positively charged. So, in between the two canonical form, the resonating structure of carbonyl group exists. So these are the two resonating forms, and aldol condensation is also caused due to generation of a new ion with aldehydes containing alpha hydrogen atom, and that new ion which is generated or which is created is known as enolate ion. Now this enolate ion, how it is formed, how it is created, itself suffers a resonance. It is resonance stabilized enolate ion is formed. Now we find that it might be an aldehyde containing alpha hydrogen atom. Now in presence of a base hydroxyl ion, what happens, that hydroxyl ion attacks the alpha hydrogen atom and takes it up as water molecule, with the result that the carbon here which was present and which contained alpha hydrogen atom is now turned to a carbon ion, and this carbon ion is known as enolate ion. Now this enolate ion, just like a carbonyl group, again suffers a resonating structure as shown here. And same thing happened. Oxygen gets negative charge in one of the canonical form, and the carbanion negative charge, it shifts over here and forms a pi bond. So that is how it happens. Now then let us see what happens. And after this formation of the enolate ion, here is the enolate ion, another aldehyde molecule is present here containing carbonyl group, that when it comes in contact with the enolate ion, it serves as a nucleophile. And the enolate ion is still negatively charged, and therefore here in carbonyl group, as we find, oxygen is partial negative charge and carbon is having partial positive charge. So with the result that they interact here and it forms a ion containing alkyl group. We call them alkoxide formation. So the resonating structure of enolate ion causes the formation of alkoxide. Alkoxide is now again in presence of a base or water, it reacts and forms the product OH is taken over here and you get aldol. Actually what has happened, if you look here, this is the alkoxide ion having a oxygen which is negatively charged, and here the aldehyde remains intact and it acts as an nucleophile. Hydrogen is taken up. Hydrogen from water is taken up or attached by this oxygen atom, and you form a compound containing hydroxy group as well as the carboxyl group, and that's why we call it is aldol. Again, one thing is very important, that hydroxyl ion is regenerated. It is again operated. So that's why we say that this base acts as a catalyst. It has a catalyzing action. Now, what happens further? If you aldol, when treated further, simply heating, since H ion and the OH ion, they exist in between the two adjacent carbon atom. Therefore, simple heating or a little acidic medium tends to remove this water. It makes it anhydrous, minus H2O. Water is eliminated, given out, and you get a final product which is dehydration of which is the result of dehydration of aldol. It forms alpha beta unsaturated aldehyde. Well, this is a very simple and easy to learn the mechanism of aldol condensation through simple 4 steps process. Now, what has happened? Again I repeat, it is nothing but the carbonyl group, the resonating structure of carbonyl group, and the presence of alpha hydrogen in a particular aldehyde or ketone causes the formation of aldol. Okay, thank you. We'll stop here. Bye.